por estar aquí. Y bueno, dispuestos hoy a iniciar nuevamente, como comenta Carlos, este ciclo de webinars orientados a nuestro propósito, que va a ser el desarrollo de la Connectathon del 2024. La, hemos estructurado una serie de webinars que esperamos eh, 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 sirvan de fundamento en todo el proceso eh, que se va a ir abordando de acuerdo a los tracks que
to the tracks that the Connectathon brings with itself. And we're joining with many of you from different countries, commenting on the cases of use and the tracks that will be developed. And obviously, this will require some adjustments, some development and standards. So we need to have these work lines addressed. The issue of fire is not new to some of you, but we know that there are groups that are new in the ministries of health teams. So that's why we need to talk about the fire standard, and we will have basically 2 sessions. This is fundamentals, but next week we will be taking more specific operations and what will be used more within some resources that will be part of the Connectathon tracks. And there are other webinars associated to the other tracks related to the standards, the web links, also the WHO or the general directory of the WHO for the digital certificates. But today we will be talking about the FHIR standard. And as I said, this is the first part. The tracks are based in the use of interoperability standards with FHIR. And we have found a key versatility so we can implement and make the Connectathon tests. And we have seen that many of the profiles and of integration that are done by the industry, well, FHIR is also implementing them. So we think it's a very good practice to get to know how the standard is structured and what resources we can start to implement and use in our purpose that basically talk about this cross-border interoperability. So today we will see some fundamentals of the standard and understand the basic concepts, where to use them and why they are being adopted in different scenarios. This is very briefly a couple of minutes to just give you the context. And even though FHIR is the standard of the present and maybe also of the future, these standards prior to HL7 are still current and are still in the page. This is an image of the website of HL7, where they will have their meeting in a month and a half, but version 2 is still current. And it's good to see this to understand. So where we use FHIR. Maybe in some cases it's good to use it, and the purpose is to understand what is the best performance of this standard and why version 2. Just to comment, I would just like to mention the scenarios of interoperability and some challenges that we've had, and probably some of you have right now in your projects and your implementation needs of information technologies and health. So at the left, we have the service providers, where normally we do the integrations or the interoperability process. And in the version 2, everything that has to do with labs, interaction with doctors, so the RISs and the PACs and the monitoring systems, and some applications, internal hospital applications also, when you have emergency information and hospitalization information. Normally, these systems have been integrated with version 2, and currently they're through the 80s, it's still very much used. Basically, it's a more mature version. And also taking into account the devices, because many devices still continue using version 2. Other interoperability scenario is between institutions. So the interoperability started using this very much because of the need to interact the clinical documents. This standard of is HL7, which basically allow to standardize the documents that are sent or inquired about different organizations. That's the logic, is to generate documents that the patient carried from one institution to the next. But this evolved, and for some time now, and much more with the arrival of COVID-19, the user and the world of apps began to be more present in the development and the applications. And not only we have applications inside the health institutions that still exist, but our users, our patients and service providers and professionals started to generate data from their own homes, or they can access information not only being in a health institution. And this is the world of the apps. This is where FHIR started being more efficient and much more versatile for implementing this. You can also do interoperability with institutions and exchanging documents, but now FHIR wants to get involved in all of these scenarios, and it can do it. And as I said, there are applications, especially at the medical image or biomedical scenarios, that is very much aligned with the messaging, even in version 2. As today, we have many documents and they are generated in different implementations on a daily basis. And that probably will give you an idea of why HL7 still uses version 2. Version 2 probably for where you have had intra-hospital devices, the CDAs, because there's millions of CDAs, and they are the basis today. In Uruguay, there's 200 million CDAs that have been gathered in 5 or 6 years, which is the implementation period, and in other parts of the world. So something that is happening, and where the new apps will probably start being developed with the FHIR standard. So this is just to say of why FHIR and for what FHIR. This is HL7 version 2, where you still have there's still many exchange of data throughout the world. This is the RIM core classes with a classes model, where this wants to talk about all of the interoperability scenarios in practice. There were some implementations where just version 3 managed to get good implementations with CDA. And they have less CDA as a standard that was consolidated with many favorable experiences in different places. These three men here realized that CDA contributed to the topics of data exchange, and using the web was not enough, because something that was more versatile was needed in terms of the information content. And this was behind the RIM, but it was a good model, but very abstract for the modeling and representation of clinical concepts. So the truth is that it could represent everything, but with high abstraction levels. So the implementation processes were not that agile. So these men knew well the HL7 systems, and they knew the new technologies, which are those based in REST, the API REST. And so they redesigned, or basically the idea is to make a standard that will not only have the contents that the standard had been working on, especially for everything that had to do with the clinical scenarios, but also the delivery of results and orders and images, the allergies, for example. All of those data models were an important capital for the messaging aspect, and all of the designs that had been done with SEA. They had to see how this could lead to a standard where it would allow not only to model, but to offer an exchange component. And the REST technology and the APIs technology was something that was evolving with the work of internet. So they knew about this REST technology, and they evolved the standard. They evolved towards the use a little bit of the models that existed, but now based on the resources, such as is defined. And this standard is called FHIR. It gathers basically all of the standard concepts, the definitions, and in addition, it incorporates a server to facilitate the exchange programs that before they needed to be done through Meet or accelerators. But REST already has a server through which information exchange happens and where the data can persist, and where you can do facades that will allow you to have access to the information accounts. But now, in a way that's inherent to the standard, it's not a third component. It's that the server is part of the standard itself. That's how the messaging standard evolved, the messages, and you have pipe, then in version 1, and then FHIR at the format level has also evolved. And we ask why version 2 had pipes, for example. well, internet was being, it was just in research. That was the context that existed. And that format, and they said, you know, will you use this with equipment throughout the world? Then internet came up, CDL, CDA came up. That was very good for documents, but then it evolved into the web applications and using the API REST. And with this technology, FHIR has put the definition of the standard on these components. This is key because probably many of you are familiarized with REST or the API REST. So FHIR is a standard supported by these infrastructures in the exchange model. FHIR is like a new generation of standards. It's very much focused in implementation. It's very simple. It's making the best use of new technology for all of the in health. It conserves the human readable and making it visible for the human being. From 2012 to 2023, that's where they began to have a totally free definition and to have a subscription or pay for it, but the chapters of countries, and they also have they make sense in existing and generating communities of learning and all of the dissemination of knowledge.
Específico para el 80%, y esto es curioso con relación a lo que era la versión 3.
This is in relation to version 3, where they wanted to define everything and the implementation did not have so much impact. With FHIR is different. I give all of this at the 80% and you can extend it. And you can generate profiles and adapt it to your context. However, this characteristic that is good also has some challenges. And what happens if each country have their own definition or profile? So the discussion is up to what point it is good for the standard to be extendable. But this has allowed flexibility and where it has been used in different scenarios. And that's part of what we will be seeing now. So FHIR works with the paradigm of resources and what where previously they had the standard, they had documents, so it uses the resources based in REST. Of the few things that we need to check in FHIR are the resources, because the resources are the representation of data models and they are the exchange units where the content is as such. In version 2, it was the messages, and version 3, it was documents that we exchanged. It was first messages, then documents, then we had to see if they were integrated or not in these structures. And we will probably will see all of that next week. But the information and what I needed to know, how do I represent information? And these are resources. And the resources are based in operations, based in networks, and in relation to behaviors. And if they have a specific identification, a known location, in relation of how you access the resources. And they have the lowest unit of transaction, and they represent all of the domains of interest for the care of health. So there are different types of FHIR resources. This standard is doing this very well because it's taking what the standard had as such, and it's also including things that had been developed before in IHE, and also issues associated to security in the infrastructure. So this is what we will be checking in the first part of the webinar. And with the types of resources, the foundational aspects, conformance terminology, security document. Then we have the base resources, is how this is in relation to individuals, entities, hospitals, where they have, these are base resources. Then we have clinical resources. There is a great richness in data models, modeling, and how you model
Por eso a veces hay un recurso de inmunización o cómo se llama.
the process, like a prescription, how you model a prescription of a medication. There are prescriptions for medications from the labs. There are resources. As I said, this was based on everything that the standard had been done before, and there were many fields that were not used. So now many clinical resources were modeled. And then we would see which are the ones that existed and which are the new ones, like genomic information, or maybe pharmacogenomic standard and environment, and to be able to model these identities. There's also financial resources where you could maybe send bills, invoices, contracting documentation, but that is in accordance with the need and use, especially with these financial issues. And because there's other financial standards too, that other countries define their mechanisms and their contracting and payment terms. It can also be modeled, but probably will not be the most robust for these entities. There are other specialized resources in like public health and research, evidence-based medicine, protocols, quality issues, and others. I think it's more than 100 resources. So really you start using the resources, and we basically just giving you a very high level overview of resources. But the case just focuses on the resources that you need for the specific case to be implemented. We will see that some resources can be interesting, for example, for monitoring and to provide results. We were talking about the apps where there's a result delivery process, and also we'll see what are the necessary resources to set up these packages for exchanging information, because the data is, you set up packages or groups of resources like a bundle through which you can generate messages or documents or transactions according to the standard. So now we will review we'll go through the FHIR resources.
Entonces, este es otro tema que también es
This
clave.
is another issue that is key on the FHIR Release 5. That's the latest release of the standard. The previous ones, the CU3, or release in draft, but as of R4, release 4, we have some regulatory implementations. Like here we have national base clinical resources, financial resources, and specialized. The foundationals are these, where we have, for example, the structure definition. This is where you define when we generate restrictions or localizations of the standard. Normally, we use these specs within the resource. That will be for the implementation of the guides, and it specifies this at the resources level. There are terminology resources where you could get, for example, G10 or the country's medications codes and procedures where you use some terminology resources and for mapping. Then there are other resources associated to security and signatures and informed consent, for example. There are other document resources, which is called composition. And probably those of you who are familiarized with CDA, composition is for making a digital document. So with this resource, you can model those documents. It's very much used to represent CDAs. And remember, I said FHIR, for example, looked at the architecture IDH for the architecture, and what they wanted to do is to index documents. So the index would identify where the documents were stored. So this has metadata to implement an ADS at the FHIR level. XDS, it's called MHL, and other resources that you could have for binary documents or files. So foundational, the base ones, this is resources for individuals, entities. Those would be base resources. Then you have clinical resources. Some of them are very good, like this one called observation for lab results, vital signs, everything that has to do with measurements, or everything that comes from the Internet of Things and what comes from base monitoring. So we'll check what that N means and these numbers. Then if, for example, I want to have interoperability for billing, there are a few resources. And what I was saying is that the personal is used mostly for clinical documentation, like medicine prescriptions. So like in medications, you have a medication request for general orders for lab tests. Then you have the request. Service request. Service request models a medical prescription. So here we have many models that could be made the most of, because the standard has much wealth of information here. Then you have the specialized, for example, for public health and research or protocols. But we will concentrate firstly into know what these numbers and what the N letter means. They have some maturity processes for the resources. And these maturity levels are of internal consensus because the HL7 committees, internal committees have agreed on this, and they have a maturity level from 1 to 5, where 1 is that it just came out, it's the first version. It's a resource that's very new, that hasn't had many levels of consensus or levels of reviews. And to the extent that these levels are developed and that they have validation, they start growing from 1, 2, 2, 3, 4, 5. And when a resource is considered a standard, it has an N. That means that the resources that have a 5 or an N are more mature resources. And in terms of interoperability, if a spec is being done, the recommendation then is to see how mature is my resource within the implementation of the standard. It doesn't mean that the others are bad. Basically, it's just saying that they don't have consensus levels that are mature, basically. And this is one of the like, for example, the patient-based resource is the one that has more maturity. And down here, we have the observation, everything that has to do with diagnostics and test results. But we will do a review of this. That's the patient resource. And this is the FHIR maturity level. So the specs is used in a standard way. We also, first we have the definition, the cases of use, who uses this resource, and what we will try to do is also to have a view of the elements of the resource. We have the resource and the different elements. That's the model of the resource as such. So they have been described. You can see what these icons are. You have the bar and the icon within the standard. You have the field and how each of the elements are structured. They have some flags also that indicate the behavior for the fields, the cardinality, and also this is associated with the data type associated to each element. And also this is associated towards the subsets or the codes that reference these elements. For example, sometimes the first thing to do is to check these codes. These are fields that are composite, and these are primitive fields. For example, name, it said it's composite name because actually it's a type of data called human name. And this is taken from version 2. So they can define these composite name fields. For example, you could say name, last name, or name 1, name 2, last name 1, and last name 2. That is called data type human name. And human name already has within this field, it has different primitives or even some other composites. So in this case, the number here you could see the use, for example, if it's temporary, official, if it's a nickname or anonymous. And here comes a very interesting topic because HL7 only defined from its origins the family and the view because it was specified by a name and one last name field. And in the here you can use various, and these are the prefixes and the suffixes. And that's when we enable a second last name. It says that it's necessary to extend the standard because it doesn't have family 1 or family 2. It goes from 0 to 1. Either it's nothing or 1, just one last name. And in the dash, it says one or many, like Fernando, Antonio, Luis, Jose, Carlos. So here it says many, and that's the reason, and that's why between the European, Australian, and American standards, it was asked that we have a second last name. So it's specifically for the region. And basically, that's to understand the type of these fields. This is a composite field, and it also, how do you define indicators, identifiers? It's like metadata associated to the identifier. Not only the type of identifier, but also to know who defined this and who assigned this identifier. That's why it's so versatility. Like this identifier will be appointed, assigned to the DNI, or this one is assigned by the hospital itself. That's why it's many fields, and like a passport type that is assigned to each. So this helps to model and how I can use identifiers at the standard level. Other fields that you see here, there's a sum signal, because when you do a list there, that's also optional, but it's not included in the sum. But the ones who in the summary, but the ones who have the sum sign, yes. From 0 to many. So most part of the data are optional, from 0 to many. So you can have many identifiers. You can have a national identification number, you can have a passport number, or it can also go from 0 to 1 or 1 to 1. But very few times are compulsory for all of them. The when it's compulsory is when you have implementation guides, as when I as a country define, if they don't bring that information, then the process doesn't continue. Where you have the extensions for the implementation. Some other composites also, and something that's interesting to see here are the benefits and the restrictions of the standard that has been modeled. For example, this is in the field gender. It says in binding, it defines the subset or the possible values assigned to gender. So there are different types of binding or subsets associated to this. In this case, it says use the binding of administrative gender, but here it says required. So to be in conformity, only use what's defined. For example, I cannot change if in the country we use 0, 1, 2, 3, I cannot change this subset to that, unless obviously only for that field. But there are countries where their gender definitions are different. For example, the ISO has a subset that's different than this one. For example, in Colombia, in terms of gender, according to the standard, they also have differences, and they didn't use this. And there are different ways of implementing this. You could do a different plan or map for this. So for this specific field, you cannot put something that's either male, female, other, or unknown. There are other subsets, like the marital status, for example. It says use these, or otherwise you can extend this to something else, like an extensible subset. You can adjust it. And there are other types of apps where it says that you can use some specific codes, or other times it says, yes, you can extend it, or the other one saying use the best that according to your criterion. There are other fields like this one, like deceased, where it could be deceased X, or I put the deceased Boolean and Boolean, or deceased date and time. This field, actually it's two. They are both allowed for the patient information. This is in general what I wanted to show you. I also wanted to talk to you about the observation resource, which is quite mature. And it's good, for example, exchanging vital signs, lab tests, imaging results, clinical findings, device measurements, device settings, clinical assessment, etc. This is a very versatile resource. I won't stop here for very long, but I would just like to tell you how we're doing in resources. For example, in version 2, there's one that's called ORU in terms of results. It is the results resource. That segment is the one that is modeled here, where you have the code, and that would be a type of observation code or type. For example, LOINC codes, that hemoglobin. If I need to do a blood delivery blood test of a specific patient in a specific date and somewhere, and it says that the value could be a number, like hemoglobin was 8.9, for example. You can put it here. Or there's a subset of values could be changed, or Booleans, and different types of data to express results, and that they are obtained from the device and they are as a product of the person's observation. Likewise, there are value references and metadata for the interpretation of results. This resource is very interesting because, for example, if you have a glucose test, it was 110, but there are results like blood test, where the blood test has 5 or 6 parameters, right? Erythrocytes and white blood count, and the same resource then I can say, you know, here we have the blood test, and each one of the contents Like, for example, in the blood test, here the blood count, here the white blood cells inside this same resource. There I can find the type and if you have devices also. And what's interesting that these observation resources in FHIR, for example, here, glucose level or hemoglobin. And FHIR talks about two exchangeable formats, XML. So here, if I choose XML, it says the code of hemoglobin, and the value is this. So that's an observation resource for a specific patient is here, and it tells you that the value of the hemoglobin test is this one. Or in JSON. In a JSON format, you have the same information, but in a different format. There's the other total, a TTL format. I haven't worked with that format, but that's another way you can have this. So the first part that is key to what we will continue doing is to talk about resources because they are the basis of this. And when we model documents, we'll do composition and then they're indexed. And the truth is that FHIR has a series of resources that help very much to advance in this project in a faster fashion. Here, there are terminological codes in the interoperability scenario. So it's good to see the patients, diagnostics, the medications, resources for anyone who would like to see the medical prescriptions. And something else that FHIR has and that are associated to the servers. One is the model and the representation of the data, but something else is how I exchange them. So what FHIR does is that it uses REST services in the architecture with the exchange in HTTP and with JSON or XML, and that's where they implement the 4 operations that exist in the worldwide operation systems. The idea is to create, read, modify, or delete, right? Create, read, update, and delete. That is implemented by REST with the read is get, the update is put, and delete is delete, CRUD. So that's how they defined a syntaxes to have access to the document, to the data directly. This is where it starts specifying some definitions on how to access the resources and the information content that have been defined. So the syntaxes and the operation specifically for get, then you have the location of the server, the name of the resource. Here you can have a specific identifier or a search parameter on a specific resource. And these can be easily implemented and it can be done easily. Well, nothing is easy, but at least we have the information and there's a FHIR server where you can do inquiries in a standard way. You can model in a standard way and access data in a standard way and create consensus for the exchange. So we will try to explore this on FHIR and we'll try to use, we didn't have the Raxel server today that we have been using for Connectathons. So we will use Colombia's server and we will recover a patient resource, an observation resource, and a medication resource. So we want to see the way how we can access these resources. In Colombia, we have a server that is used in the country's ecosystem. For those of you that would like to know where you can get a FHIR library, but inside the LACPASS project, we create some Dockers that are distributed. But also for those of you who are interested in advancing in these topics, these are all based in libraries and disposed by HappyFire. HappyFire has some public servers and they have the documentation that will also help those who are integrated in the deployment of these types of servers. But we have downloaded some libraries and we are making them available in a Docker, and that's part of the LACPASS project. And finally, we will try to look for Volcano. Volcano is a FHIR server. That's a HappyFire. It was downloaded and was put here. And this is a sandbox that is used in the country for training purposes in the ecosystem in terms of the interoperability. So at the left, we see the resources. These are resources that are part of the standard. And the CRUD operations. If you want, let's try to send a resource. The users are also familiarized with the REST content, but to do something basic like this, I have the XML, a patient resource, and we will create it. That's basic information and the names and the gender. So basically you just do this to have the FHIR answer, response, and REST. So if I create it, okay, it says 201, that means it's okay. And then the address returns where I have created this patient. And this is set up with Volcano. So if we could set this up, we're creating this patient. Here you have the URL and it says inquiry, and somebody who had done this. And then we have a post where we send the data of this patient. If you would like to, some of you could also send maybe a post to our server also. I copied the resource and you can do it. So maybe they can send us the URL by chat. And in the meantime, we have a couple of minutes to answer questions because really time flew and I think we're running out of time. So if you think and then honor time, so if you can try to modify that last XML that I sent you and send it and share it in the CRUD and send the URL through here of your resource. And every time that you create a resource, that creates a number. That's a volcano chain. But if there are any questions, if you want to ask a question, we have a few minutes left.
Fernando, para el escenario de
For the Connectathon scenario,
vamos a trabajar igual
are
cada
we
país
going, every country will have their own fire and will have a block test, just like we had last time, right? Or it's based on volcano? No, that's the server here in Colombia, and we will upload a sandbox for LACPASS. And in fact, each country, and it will be similar to the Connectathon that we had in Brazil. The idea is that each country has their own FHIR, their own test server, where we can also use a broadcast and do the searches and inquiries between the different servers. That is the broadcast. Because in the Connectathon, you will be able to access this through apps. And where we will have other accesses, which will be the QR codes, but the architecture, basic architecture will be the same, but we will add each country's app. And we'll work with the same Docker as last time, the same Docker. Oh, yes. We're starting to warm up the motor, so I think in Costa Rica, they have been working on that. Maybe they can also present their experience with that. But that's the line, to continue with the Docker, an updated Docker. I see that my colleague, I don't know, Panchi, would like to share the resource. From Ecuador. Any other question, concerns? This was an initial and basic topic, but the idea is to grow this in the coming weeks in this road towards Connectathon in the month of October. for LACPASS. Carlos,
Le cedo
I give the floor to you. Thank you, Fernando, for your presentation. As you say, this is the first of a cycle in preparation for the coming Connectathon. Just like to say that the next session is at the same time, but on Thursday 11, we will send you the access links, and these are with a registration. You complete the registration and then you get the code back into your email. But we will put that in writing if you have any questions. We will wait for you for the next session. We also have a technical committee tomorrow, and at least we will leave that already written down for this year's Connectathon, because then we start checking the local nodes of each country. So thank you all for your attendance today, and this will be recorded and available if you would like to revisit this session. Greetings and goodbye.
pronto. Muchas gracias.
Thank you very much.
Está muy bien, muchas gracias.
Chao, chao.